Hello everybody and welcome to video 7 in this Python OpenCV tutorial series. In this video, we're going to be talking about template matching. Now, when I say template matching, I pretty much mean detecting an object or a template image in another image. So for example, I have this image of a soccer practice. I just took this off of Google Images and we have a soccer ball. We have, some different people here. Some of them are wearing shoes, or they're all wearing shoes that are slightly different colors. And what we're going to do in this video is we're going to detect this ball, try to figure out its location in this image, and specifically detect this dude's left shoe. Now, we also could detect other things in this image. We could try to detect the referee. We could try to detect the light post or whatever this is here. All kinds of different things. We could try to detect the mesh, but it makes sense and it's a lot easier to detect kind of a larger object that's actually in focus. So say the ball or this guy's shoe. Anyways, that's what we're going to be doing. So I have this image on GitHub. You guys can download it if you want to follow along with this specific image. I also have an image of this dude's shoe and of the ball. Now, it's very important. These are going to be what we call our template images here, the images that we want to locate in the base image. It's very important that these template images are the same size or close to the same size as the image in our base image that we want to locate. So what I mean by that is this image, let's say it's like 1500 by 1500 in terms of pixels, width, and height. That would make our ball maybe, 150 by 150 or 200 by 200 pixels, something like that, if you were just drawing a rectangle around it. So you want to make sure that your template image of this ball, so ball.png right here, is around 150 by 150 or 200 by 200 pixels, such that it's going to be easier to find this in the base image. So if your ball here was say like 1000 by 1000 and your base image is 1500 by 1500, it's going to be very difficult to find this ball because the ball that you're passing as the template is more than half the size of the image, right? So just keep that in mind. You want your template images to be as close as possible to the actual size of the image you want to locate in the base image, or the object you want to locate in the base image. Anyways, my images are as close as they possibly can be. I quite literally just took a screenshot from this, so it should give me pretty well accurate dimensions, and we'll see how it works in this tutorial. Anyways, get your template image or template images, get your base image, bring them beside your script or in the assets folder like I have it, and then we can move on. All right, so the first thing I'm going to do here is I'm going to say import numpy as np. I am then going to import cv2. Now what I want to do is load both my template image and my base image. So I'm going to start by saying image. We'll do my base image first is equal to cv2.imread. And I'm going to read from the assets folder and then slash soccer underscore practice.png. Or sorry, this is JPEG. Okay. Then after I have that, I'm going to load in my template. So template is equal to cv2.imread and then assets slash, and then what did I call this one? This is ball.png. We will use the shoe after, but for now I'll just load in the ball. Then quite quickly, I'm just going to make a copy of this this base image here, and we'll discuss why in 1 second. I'm going to say image2 is equal to image.copy. I also want to load both of these images in as grayscale. So I'm going to put a 0 here to load them as grayscale. Now, the reason I want to load these as grayscale is because just like many of the other algorithms in OpenCV, the algorithm we're going to be using here requires grayscale images. So we just load them both in as grayscale. Now I'll discuss why we made the copy in 1 second, but I'm going to get the height and the width of my template image. So I'm going to say height, comma, W or H, comma, W is equal to, and then template.shape. Now, the shape of my template image is actually going to be a tuple that simply has the height and the width, so the number of rows and the number of columns. This is unlike when we load in a colored image that would have a shape of height, width, and then channels, where channels is most likely going to be equal to 3. It's going to be storing the B, G, and R values. Now, since this is a grayscale image, we only have one integer value between 0 and 255 representing each of our pixels. So we don't have this third dimension to our array. And just to show you this, if I print out img here, we can see that this is a 2-dimensional array, not a 3-dimensional array, because this is a grayscale image. So when we get the shape of our template image, that gives us the height and the width. All right, so now that we have that, I'm just going to paste a piece of code in here. I will explain it. This is called methods. Let me grab this from my other screen here. All right, so methods. So these are all of the different methods of doing template matching. So just like in some of the other algorithms, there's different properties or values you can pass to these algorithms, and it will make them perform a little bit differently, right? There's different methods. So in this case, there is 6 main methods of doing template matching. These are all of them. I would recommend you just copy this in. I'm not going to explain what all of these methods are and why you would use each of these, but what's recommended in the documentation is that when you're starting to perform template matching, you try with all of the different methods. Then the method that's giving you the best result is the one that you continue to use afterwards. So I will link the documentation in the description if you want to see more about these, but they're just slight different ways of performing this template matching on our images. So these are the ones, we have them in a list. So what I'm going to do is I'm going to loop through all of these methods. I'm going to say for method in methods. And for every single one of these methods, I'm going to try to perform this template matching. And we'll just see which one does the best. We'll show all of the results, and then we can kind of pick which one we want. So we have for method in methods. And then what I'm going to do here is I'm going to say image is equal to, and then image2 dot copy. Actually, now that I'm writing this, I'm realizing that I don't need to make the copy here. I can remove that. I'm going to say image2 is equal to, and then image.copy. I don't know why I was writing that above. Okay. Anyways, ignore that line that I wrote previously. That was wrong. We're just going to say image2 is equal to, and then image.copy. The reason I'm copying this image is because I want to draw the rectangle on this image. And if I just drew the rectangle that shows where we're finding the template image on the original image, then I would have multiple rectangles on that by the time we got to our last method. So for each method, I need to have kind of a new starting image. So I'll just copy the base image right here. Okay, so now that we have this image copied, what I can do is actually perform the template matching. So I'm going to say result is equal to, and then this is going to be cv2.match template. I'm going to pass my base image, which is image2, and then I'm going to pass my template. Now, what this method is actually going to do for us is perform a convolution. Now, a convolution essentially involves taking our template image and kind of sliding it around our base image and seeing how close of a match there is in every single region of our base image. So what this is going to return to us is going to be a new image. I'm hesitant to call it an image because it's not really an image. It's going to be another two-dimensional array that's going to tell us roughly how accurate of a match there is in each region of our image. Now, the resulting image here, or the resulting 2D array, is going to be of the size of the following. It's going to be width, so W minus W plus 1, and then H minus H plus 1. Now, you could do it in the other order if you want to do height first, then width second, but the dimensions of this two-dimensional array is going to be the following. Now, when I say W and W, the uppercase W is standing for the width of our base image. So the uppercase W, width of the base image, so the larger width. Then the lowercase w is going to be the width of our template image. Then we're going to add 1. Now, the reason we get this is because when we're performing a convolution, we're essentially taking this template image, and as I said, we're just dragging it around. So we're going to be checking W minus W plus 1 positions in the width or on the x-axis as we slide this around. Now, let's do a really basic example. Let's say we had an image that's 4 by 4, and then we have a template image that's 1 by 1. Actually, this is probably going to be a bad example. Let's say we had a template image of 2 by 2. So this means W is equal to 4. This means that lowercase w is equal to 2, H is equal to 4, and H is equal to 4, and lowercase h is equal to 2. So if we run this equation, we're going to get a dimension of our output array here from this function that's going to be the following. So 4 minus 2 plus 1, that's going to be 3, and 3. Now, the reason we're going to get 3 by 3 is because that's the number of times we can slide this image in the x direction and in the y direction. Let me try to do a little bit of an illustration here. So we will continue in 1 second, but I need to quickly thank the sponsor of this video and this series, which is AlgoExpert. AlgoExpert is the best platform to use when preparing for your software engineering coding interviews. They have the highest quality coding interview questions on the platform, a data structures crash course, they have behavioral interview tips, and really it's just a great platform that makes it much easier to prepare for your software engineering coding interviews. So with that said, check out AlgoExpert from the link in the description and use the code TechWithTim for a discount on the platform. All right, so I've written out a little bit of an example here. We have a base image and our template image. And what we want to do is take this template image and slide it over top of the base image. So where would we start this? Well, we would start sliding it at these 4 values. So the ones that are on line 23 and 24, and then the first 2 elements in these arrays. So that's where I would start this, template image as I'm sliding it around. So what's going to happen is we're going to take this template image, we're going to overlay it on top of these 4 pixels here, and we're pretty much going to say, all right, how much of a match is there? How matching are these 2 images? Now, in this case, this is an identical match, right? All 4 of these pixels match. So what that tells us is, hey, this was a perfect match. So we mark that now in an output array. So if I'm creating some type of output array, let's just do this. And I don't know why it keeps auto-correcting and adding numbers here, but you get the idea. We have some output array. And for the first value in our output array, we're going to put a 1. Now, we might not actually put a 1, but I'm just going to put a 1 to indicate, hey, these values match. So then what we'll do is we'll say, all right, well, we figured out that in this quadrant or this region of 4 pixels, they match completely. So what we'll do after that is we'll take this now and we'll slide this to the right. So we'll say, okay, we're going to forget these 2 values. So the first 2 elements in the arrays at line 27 and line 28. And then we'll look at these 4 elements, which are kind of in the middle here. I'm kind of circling it with my mouse. So we look at those and we do the same thing. We say, how much does this match? Well, it matches perfectly. So we add a 1 now here in our output array. Then we slide again to the right and we see, okay, well, these match again perfectly. And so we add another 1 in our array. Now we've done 3 slides, or we've moved to the right 2 times. So we looked at 3 different positions. Now we reset. So we go down 1 row and we start again over here. So now we look at these 4 elements. So I'm kind of again circling with my mouse and we say, is there a match? Yes, there is. So we add a match right there. We then slide over to the right. We say there's a match. We then slide over to the right again. We say there's a match, and we continue this and we'll see that we have an array that now has 9 elements and pretty much tells us that, hey, this entire image matches this template image. Now, usually that's not going to happen. I was just trying to show you how we create this output array. So this is how you figure out the size of this output array. It's not necessarily important that you understand why it's that size or that you even understand what the size of this array is, but I just wanted to show you kind of how this works. So that's the idea here. And then this array right here will tell us how closely areas in our and then this output array right here is going to tell us how closely areas in our base image match with our template image. So now what we need to do is look in this image right here, or look in this output array, and try to figure out which value is the highest or which value is the lowest, telling us which values or which areas match the most and which areas match the least amount, right? That's what we want to do. So if you were to imagine that we had a bunch of zeros here, so there was like no match at all, other than say maybe right in the middle, then what we would want to do is we would want to find this 1, because this is the area in our base image here that matches. So then we can do a little bit of math here to figure out, based on this output array, where this area actually is in the original base array. And then what we can do is draw a rectangle. So there's a lot to go into here. It's very hard to do this without a whiteboard and kind of drawing everything out. But hopefully this gives you a general idea of how this works. You're sliding this around. You're then creating an output array, which is going to be the size of this. The reason it's the size of this is because that's the number of times that you can slide this template image through the base image. And then you look in this output array, you figure out what the maximum or minimum value is depending on the method that you're using. And then you take that and you try to kind of reverse engineer where this position is going to be in your original base image. Then we can draw a rectangle there, and that's what we need to do. So I apologize for the lengthy explanation, but hopefully you appreciate that, and that kind of describes to you how this template matching actually works. It's a little bit more complicated than that, but that's the basic idea. So now that we have this, what we want to do is we want to take this output array and we want to do what I just said. We want to find the biggest value and the smallest value, because depending on the method we're using, the biggest value will be a match or the smallest value will be a match. So we're going to say min underscore val, and then max underscore val, and then min underscore loc, standing for location, and then max underscore loc, standing for location again, is equal to, and then this is going to be cv2 dot min max loc of result. Now, all this is going to do is return to us the minimum value in the array, the maximum value in the array, the minimum location, and the maximum location in the array. That's what it's going to tell us. So that's what we get from this here. It just looks in the array and it will give us those values. Now, we don't really care what the min and max value is. We just care about the location of the min value and the location of the max value. So if I actually print out min underscore loc and max underscore loc, then what we can do is run this and we'll just see what this location actually is. So let's run this and we got an error. Let's see what this is. Missing one required argument, method. Okay, so after we have image2 and template, we need to pass our method here. I forgot we were looping through all the methods. We should probably pass it. So for match template, base image, template image method. All right, so now we can see here that we get all of our different locations. So it's telling us the location in this, this array right here. And then what we can do with that as well, we can use that as, say, the corner of a rectangle. We can draw a dot there or something like that. So anyways, those are the locations. So now that we have the locations, all we need to do is draw a rectangle where these locations actually are in our base image and display that image so we can see if it actually did match the correct area. So what I'm going to do now is I'm going to say that if the method is in, and then this is going to be cv2.tm underscore and then sqdiff, and then cv2 dot, and then this is going to be tm underscore and then sqdiff underscore normed. Now, the reason we're doing this is because these two methods right here, if we use these, we want to take the minimum value. If we don't use these, if we use any of the other four methods, we want to take the maximum value, or sorry, the minimum location and the maximum location. It's just based on how these methods work. So I'm going to say that location is equal to, and then min underscore loc, and then otherwise location is equal to max underscore loc. So sometimes the max is the best, sometimes the min is the best. When it's these two methods, the min is the best, otherwise max is the best. And so that's why we're doing this. Now that we have the correct location, what we're going to say is the following: cv2.rectangle, and we're going to draw a rectangle on our image2, so the copy of this image, and then we're going to draw it where? We're going to draw it at location, so this will be the top left-hand corner of our rectangle, and then we need to draw it at another position, right? So we have to have the top left-hand corner and the bottom right-hand corner, so I need to figure out what the bottom right-hand corner of my rectangle is going to be. Now, if I have the location of the top left-hand corner of my rectangle, and I know that the image I'm looking for is, well, the size of my template image, then all I have to do is the following. I can say that my bottom, let's see, underscore here, bottom underscore right is equal to, and then this is going to be a tuple of location 0 plus my width, and then location 1 plus, and then my height. Now, the reason this will work is because if we know that the region we're looking for is the size of our template image, if we have the top left-hand corner, then to find the bottom right-hand corner, we just have to add the width, so in the horizontal direction, and then add the height in the vertical direction of our template image, and that will give us the bottom right-hand corner. So it will give us a rectangle that has the same size as our template image. So now I can draw this at the bottom right, and then the color, I'll just make it black. So we're drawing a black rectangle because this is going to be grayscale, so I don't pass 3 values. And then do we want to fill this in? No, we probably don't want to fill this in, so we'll do a line thickness of, say, 5. Then we can show this image, so cv2.imShow, and we will show image 2, and this will just call, I guess, actually, let's call it match like that. And then finally, we'll say cv2.waitKey0, and then cv2.destroy all windows. So this will now go through and it will show us 6 different windows. So let's run this and let's see what we get. And we got an issue. Let me have a quick look here. All right, so I realized I made a pretty silly mistake. Width has to change to W and height has to change to H because I didn't actually spell these out fully. I just did HW. So anyways, now that I fixed that, I should be able to run this. And there we go. We can see that we have detected the soccer ball in this image. We have drawn a rectangle around it, and that was using method 1. That worked. So now I'll press any key. It will now show me method 2. See, we detect it again. Method 3, notice that method 3 didn't work, right? It's showing me this, which is obviously not the soccer ball. So that detection method just was not very accurate. So we wouldn't use that again. And then you can see we found the soccer ball, soccer ball, soccer ball, and now all 6 of our methods are done. So that is how you do template matching. It's pretty straightforward. You just have to understand kind of how this works so that you actually can determine, how to draw the rectangle and what all of this is really doing and what the min location is and the max location and all of that. Anyways, now what I'm going to do though is just show you how this works for the shoe. So let's change this to shoe.png and let's run this. and my image is too big to see the shoe. So that means I have to resize my image and make it a tiny bit smaller, because right now I just cannot see the shoe because this doesn't fit on the screen. So can I actually resize this window? No, it doesn't look like it. So let's actually just go ahead and resize our thing here. So I'm going to say cv2.resize, and we'll resize loading in this image. We'll say 0, 0, and then fx equals 0.9 and fy equals 0.9. That might still be too big, but let's run this and see. And what is the issue now? Let's have a look. It says CVS is not defined, so it means I have to spell this correctly. Now let's run this. Okay, so now it's still, damn it, it's still, what do you call it? Too big. So let's make this a bit smaller, 0.8 and 0.8. Okay, so now you should be able to see the shoe. Okay, so this is obviously detecting it wrong, but let's go to the next method. That's detecting it wrong too. That's detecting it wrong. That's detecting it wrong. That's detecting it wrong. Okay, so the reason this detecting it wrong is because I've resized my image, but my template image is now bigger than what it really should be in this image. So I'm getting this error. So now since I've resized this base image, I also need to resize my template image. So I'm going to say cv2.resize, and we'll just do the same resizing, so the same scale, so that this is going to work properly. So now we'll go 0, 0, and then we'll say fx equals, in lower cases, fx equals 0.8, and then fy equals 0.8. Okay, so that should hopefully work now. What's going on with my brackets here? Okay, I think that's good. All right, so let's run this. And now, okay, that's still wrong. This one now has detected the shoe correctly. This one's wrong. This one detected the shoe correctly, shoe correctly, shoe correctly. So you get the idea. Doesn't work perfect every single time. Each method has a different accuracy level, and the size of your template image and your base image is very, very important. So that's all I wanted to show you. That's how you perform template matching. Hopefully that gave you an understanding of what this is actually doing, how the convolution works on kind of a simple level, and then how you can perform this on your own images. So with that said, if you guys enjoyed, make sure to leave a like, subscribe to the channel, and I will see you in another YouTube video.